we will do an activity that show that acidic behavior. Acid show acidic behavior in the presence of water, or we can say that acid do not show acidic behavior in the absence of water. In the absence of water. This is the one activity we will do. This activity about acid do not show the acidic behavior in the absence of water. Okay, so one acid will do not show the acidic behavior in the absence of water. So acid will show acidic behavior. When the acid will show acidic behavior, acid
if it is displayed in water.
Yeah, acid will show acidic behavior only in the presence of water. Okay, presence of water. So we are doing one activity where acid do not show the acidic behavior in the absence of water. Okay, in the absence of water. So for that, we have to take one test tube. Okay, in that test tube, we have to take a sodium chloride. Sodium chloride, we have to take sodium chloride. Sodium chloride. Sodium chloride. Sodium chloride. And you have to add a concentrated sulfuric acid. We have to add a concentrated sulfuric acid. We have to add a concentrated sulfuric acid, means H2SO4. Okay, sulfuric acid we have to add. Sulfuric acid we have to add. Sulfuric acid. This is the concentrated sulfuric acid I have added. Okay, so this reaction, what is this reaction? Because here you have NaCl, sodium chloride plus concentrated sulfuric acid. Then when they will combine, what will get?
Sodium sulfate.
Sodium sulfate, Na2SO4 plus HCl, correct? HCl. Okay, so HCl here, H2 NCl, so here 2 HCl, so here 2 NaCl. So HCl will get here. Here you will get HCl. Okay, HCl you will get. So here HCl is actually will get in the form of gas. Okay, HCl you will get in the form of what? Gas. So here this mouth of the test tube I have to close with the rubber cork. Okay, with the rubber cork I have to close the mouth of the test tube. Okay, and I have to fix here one delivery tube. Okay, one delivery tube I have to fit it to this rubber cork. This is a delivery tube. So whatever the HCl gas is produced here, HCl gas is produced. So this HCl gas will be delivered by the delivery tube. Okay, it will be delivered by the delivery tube. So acid do not show acidic behavior in the absence of water. That activity we are doing. In that activity, we have taken the sodium chloride and added concentrated sulfuric acid. Concentrated sulfuric acid. So when this reaction will takes place, there is a formation of sodium sulfate and hydrochloric acid. Hydrochloric acid. Okay, hydrochloric acid. This hydrochloric acid is in the form of gas. So hydrochloric acid you will get in the form of water gas. So hydrochloric acid will be coming out from this in the form of gas. So what we have to do here, you have to bring one litmus paper. Which litmus paper you will bring here?
Sir,
Blue
blue.
litmus.
Blue, sir.
Blue, sir.
Blue litmus paper. Blue litmus paper. Okay. So what is that here now? Here HCl gas will be produced. But which HCl gas will be produced? You know, that is a dry HCl gas will be produced. Dry HCl gas. If it is not dry, then you have to use one guard tube. Okay, one guard tube you have to use. One guard tube. In this guard tube, what is contained? Calcium chloride is present. Calcium chloride. One guard tube you have to use. Okay, guard tube, it is given in your textbook. See, the side one small diagram is given. Okay, like this. Guard tube. Guard tube you have to use here. In this guard tube, what we have? Calcium chloride. So this
Calcium chloride.
guard tube you can fix here. Okay, this guard tube you can fix here so that if the HCl gas whatever produced, if it is not dry, then if it is passing through this guard tube, calcium chloride will make this HCl gas dry. Okay, in the first chapter you have learned that while using that activity, one iron and nail activity, when we are deep into the water, okay, so that time we have used this calcium chloride for the absorbing the moisture. So calcium chloride will absorb the moisture. Whatever the moisture present in the HCl, means whatever the water present in the HCl, that will be absorbed by this calcium chloride and the HCl gas will become dry. Okay, so now here water, the dry HCl gas is passes through what? It passes through water, dry blue litmus paper. It passes through dry blue litmus paper. So whether any changes of color for this blue litmus paper?
No, sir.
No.
See here, HCl gas is a dry, the litmus paper is also dry. So when the dry HCl gas is passes to the dry blue litmus paper, there is no change in color. Why there is no change in color?
Because there is no presence of water.
Yes, the water is not present. In HCl gas also water is not present. In the blue litmus paper also water is not present. Suppose now the dry HCl gas, if it is passes through the wet blue litmus paper. Wet blue litmus paper. Whether there is any change in color?
Yes, sir.
Whether there is any change in color, whether the blue litmus paper will changes to the red?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So this paper, wet blue litmus paper turns to red.
Red.
Yeah, red. Okay, suppose now if I'm taking the solution of HCl, solution of HCl means what? The solution of HCl nothing but water is
Aqueous.
present, correct? In HCl, the water is present. Now this solution of HCl is passes through the dry blue litmus paper. So whether any change in color?
Yes, sir.
Yes, sir.
Yes, so the dry blue litmus paper also turns to red.
Red.
So in this 1, 2, and 3, what you have observed that? So from this activity, we have concluded that that acid do not show the acidic behavior in the
Absence of water.
Absence of water.
Option C here. Here is a HCl. This HCl is an acid. This acid will not change the color of blue litmus paper to the red. Okay, why they not change the blue litmus paper to red? Because the water is not present. So the HCl will not show the acidic behavior. HCl will not show acidic behavior in the absence of water. HCl will show the acidic behavior only in the presence of water. Water.
Water.
Water.
Water.
Yeah, only in the presence of water. So in the textbook, there is a one question is there. What is the question? You know, one question. There is a textbook that why does dry HCl, why does dry HCl gas not change the color of change the color of the dry blue litmus paper, of the dry blue litmus paper? Okay, that is one question from your textbook, NCERT question. This is the NCERT question. Why does dry HCl gas not change the color? Why the dry HCl gas not change the color of the dry blue litmus paper? Why it is not changing the color? Why it is not changing the color? Why?
Because there is no presence of water.
Okay, that is true. But what is the requirement of the water here? What is the requirement?
So
of
the acids will not dissociate into its ions.
That is important. See, that HCl will be dissociated to form the H plus ion only in the presence of water. But here the water is not present, so the HCl will not dissociate. HCl gas will not be dissociated to form the H plus ion. That is the correct answer. So HCl gas does not dissociation, does not undergo dissociation, because it does not undergo dissociation. Okay, HCl does not undergo dissociation to form what? To form H plus ion. Okay, in the absence of water, in the absence of water, in the absence of water. Okay, in the absence of water, in the absence of water, in the absence of water. So therefore, the last answer, what again? Therefore, the dry HCl gas, therefore dry HCl gas will not change the same question. What is there? No, same we can write. Therefore, dry HCl gas not change the color of, the dry blue litmus paper, dry blue litmus paper. Okay, here blue I have to write. Okay, blue, dry blue litmus paper. So see that acidic characteristics. HCl will show the acidic character only in the presence of water. What is that reason here? Because in HCl in the presence of water dissociate to form the H plus ion. If the H plus ion is formed, then only that HCl gas can change the blue litmus to the red. Otherwise, it will not change the blue litmus to red. Compulsory, in the acid, the water should be present. So this activity shows that the acid do not show the acidic behavior in the absence of water. Why it not show the acidic behavior? Because HCl gas will not dissociate to the form H plus ion in the absence of water. HCl gas does not undergo the dissociation to form H plus ion. If it show the acidic behavior, if it is showing the acidic behavior, means there is a water should be present. Okay, the water is compulsory for the acidic behavior. If the water is not present, then it will not show the acidic behavior. So if I'm taking now here HCl solution. So in the question, in the activity one more question they are asking that. So what is this activity conclusion? What is the conclusion for this activity? Conclusion.
The acids show acidic behavior only in presence of water.
Or we can say that the activity concluded that acid do not show acidic behavior in the
Absence of water.
absence of water. So this activity concluded that the acid do not show the acidic behavior in the absence of water. This is the activity conclusion. So this activity, if you want to do, this activity shows that acid do not show the acidic behavior in the absence of water. We have to take the sodium chloride, okay, and we have to take concentrated sulfuric acid. So when the sodium sulfate will be produced, and you will get the hydrochloric acid, which is in the form of gas. But we have to make this HCl gas dry. Okay, for dry HCl gas, what we have to use? For making the HCl gas dry, what we have to use?
So guard tube
Guard tube.
Guard
contains a
tubes.
calcium chloride.
Yeah, we have to use the guard tube which contain the calcium chloride, which calcium chloride absorbs the water present in the HCl gas, and that makes the HCl gas dry. Okay. So now this dry HCl gas is passes through what? A blue litmus paper. There's a dry blue litmus paper. Then there is no change in the color. When it is passes through the dry blue litmus paper, then there is no change in color. It shows that acid do not show the acidic behavior in the absence of water. Okay, it only change the color when the water is present. Okay, so here that is this activity. So if I give you here HCl solution, whether the HCl solution will show the change in color for the wet litmus paper and dry blue litmus paper?
Yes, sir.
Yes, sir.
Yeah, so we can say the color of both wet and dry blue litmus paper change to what? Red. Litmus paper turns to red. So HCl solution. Why the blue litmus paper change to the red here in the HCl solution?
Because it is acidic, sir.
Presence of water.
In the presence of water, correct. Because of the HCl solution, water is present, and the HCl will be dissociated to form the H plus ion. Correct answer. HCl solution will change the color of blue litmus paper because HCl solution contain the water, and the water will be dissociated to form the H plus ion. Okay, and that is the reason this HCl solution will change the color of both wet and dry blue litmus paper. Got it? Any base that dissolve in water, is called, what is called? Alkalis or alkaline. Alkalis or alkaline. So can you say which bases? Now we have sodium hydroxide, magnesium hydroxide, calcium hydroxide, potassium hydroxide, sodium oxide, potassium oxide, calcium oxide, magnesium oxide. So this is also a base and this is also a base. So which base dissolve in water here? If you want to see which base are dissolved in water, then how you come to know that?
By hydroxide, sir.
So if you want to know that which base is dissolved in water, so always remember that the base which is ending with the bases ending with hydroxide. Okay, the ending with the hydroxide. The bases ending with hydroxide are dissolved in water. Please remember that the bases which is ending with hydroxide are dissolved in water, and they are called what they are called, and they are called here given, see, and they are
Alkaline.
called alkaline or alkalis. The bases which is dissolved in water, okay, are called alkaline. The bases ending with the base which is ending with hydroxide, they are dissolved in water, and they are called what? Alkaline. The bases which are ending with hydroxide, they are dissolved in water, and they are called alkaline. So when the base is dissolved in water, when any base is dissolved in water, what it produces? Base dissolved in water. Only the base. Here, where is the salt here? Bases. When the bases dissolve in water, what they will form? Suppose if I ask
OH minus ion.
OH minus ion. That is correct. Bases, when the bases dissolve in water, they form what? OH minus ion. Correct. That is the correct answer here. When the bases dissolve in water, they produce OH minus ion. So what I can say that bases produce OH minus. What is this OH minus is called? That is called
Hydroxide.
hydroxide. That is called hydroxide ion. OH minus ion or hydroxide ion in water. So bases produce OH minus ion in water. In water they produce OH minus ion. Okay. So example now here, see NaOH. When it is water is added, when the water is added, okay. So if you do not want to write here water, suppose if you do not want to write here water, then what you should write, in the bracket you can write here AQ. So that is called what? Solution of hydroxide, isn't it? Solution of hydroxide. So here sodium hydroxide is dissolved in water. So it dissociate to form Na plus, that is aqueous, plus OH minus ion. There is also the aqueous, and this is called what? Hydroxide ion. Hydroxide ion, and this is called what? Sodium ion. Sodium ion. Okay. And this is NaOH is called a sodium hydroxide, solution of sodium hydroxide. Okay. This is called a solution of sodium hydroxide, NaOH. Suppose now if I'll give you KOH aqueous, means the water is present, then dissociate to form. What it dissociate to form?
K plus and OH minus.
K plus, that is aqueous, and OH minus, that is also aqueous. Correct. So this is called a KOH plus K plus OH minus. If I'll give now here MgOH twice, magnesium hydroxide aqueous, then there is a
Mg plus OH minus aqueous.
here the student will do mistake. Okay, here
Mg2 plus.
Mg2 plus will come. Why? Because the magnesium ions. What is the magnesium ion? That is a 2 plus. Always the magnesium ion is 2 plus. So this ion will not change. It will come 2 plus only. Okay, and obviously OH minus. This OH minus also same only. But here I should write 2 OH. Why? Because here you can see that there are 2 atoms of OH. That is why. Here 2 atoms of OH. That is why I write here 2. So this OH minus ion is also same. It will not change. Magnesium Mg2 plus also will be same. It will not change. Potassium K plus, always the potassium will come in the K plus. Magnesium always will be formed in the Mg2 plus. Okay, Mg2 plus. So if I give now one more here, calcium hydroxide, CaOH twice. Now can you say what is the dissociative?
Ca2 plus plus
Ca2
O, so plus 2
2OH
OH.
minus.
2OH minus, exactly correct, very nice. So that is now whenever the water, whenever the bases, any bases dissolve in water, so what they will form? Any base dissolve in water, what they form?
Hydroxide ion.
Hydroxide ion.
Hydroxide ion.
Hydroxide ion.
Hydroxide ion, exactly correct. So now my question is whether bases conduct electricity. Okay, when the bases conduct electricity, when the bases conduct electricity.
When they are added in water.
Yes, the bases, or we can call as a alkalis, the bases conduct electricity, but only in the presence of water. The bases conduct electricity in the presence of water, Okay, the bases conduct electricity in the presence of water. And who's responsible for conducting electricity for the bases? Who is responsible?
OH minus ion.
Exactly correct. Hydroxide ion, OH minus ion are responsible for conducting electricity, Exactly correct. So OH minus ion is responsible for conducting electricity. So here in the starting of this chapter also we have learned some of the points about that. What is that point? Bases are bitter in taste. And what is now? Bases are soapy to touch. Bases are soapy to touch. Okay, bases are soapy to touch. The third point, what we remember, bases, what is called as bases turns blue, red litmus paper to blue,
Blue.
to blue. And we have learned about that bases react with what? Bases react with metal to form salt
Hydrogen gas.
and hydrogen gas. Okay, and the fifth one bases react with acid. Bases react with acid to form salt and water. Now today we have discussed here that bases dissolve in water. Bases dissolve in water. The bases which dissolve in water are called any base dissolve in water.
Alkali.
Yeah, it's called alkalis or alkaline. Okay, alkalis or alkaline. And what is the bases ending with hydroxide are dissolved in water.
Water.
Are dissolved in water, and they are called alkaline or alkalis. Okay. The 8th point, what we have learned, that bases produce. What the bases produce? The bases produce OH
Hydroxide
ion in
OH
water.
minus.
And the 9th point, we have learned that bases conduct electricity. Bases conduct electricity in the
Presence of water.
presence of water. See, the 9th point we have learned about the bases. If you remember this 9th point, then any answer you can able to write if the question come based on the base. Now, here we are going to learn diluting an acid. Okay, diluting an acid. What is mean by diluting an acid? Diluting.
Adding acid to water.
Yes, means water and acid we are mixing. Okay, acid and water we are mixing, or we can say that acid is adding in the water, or water is adding in the acid. Okay, so if there is an acid, then if you will add water, okay, then the acid is become water diluted. Then acid become diluted. See, last time we have learned about the concentrated. What is the difference between concentrated and diluted? Concentrated, it is present, but very minimum amount of water present. Very minimum amount of water is present. Minimum amount of water is present. Minimum amount of water is present. What about the diluted? Diluted is what? Much
Maximum
more.
amount of water.
Yeah,
Maximum amount of water.
maximum amount of water is present. Maximum amount of. So that is the difference between the concentrated and diluted. Okay, the concentrated nothing but the minimum amount of water is present, and diluted nothing but what much more amount of water is present. So this now, when the water is now adding in the acid, or acid adding in the water, then it is called what? Diluting an acid. But there is one process is there, how you can add water to acid, how you can dilute the acid. So if you have, now if I given here one, here there is an acid, okay, there is a concentrated hydrochloric acid, and here you have the water, okay, here you have the water. So now the what you will do now, how you can make this acid dilute, how you can make this acid dilute. Okay, so if you want to make this acid dilute, we have to add the water. So how, whether you will add acid into the water, or you will add water to acid. Okay, that is important. So always remember that acid, you should add the acid in the water. Okay, and that is also very slowly. Okay, acid should be add in the water, that is also very slowly, drop by drop. Okay, and you have to stirring this mixture also, you have to stir this mixture also. Acid should be adding in the water drop by drop, and you have to stir this mixture. Okay, if you are doing in another way, if you are doing in other way, means if you are adding water to the acid, so water to acid, when you are adding, then that is exothermic reaction will be takes place here. Exothermic reaction, nothing but heat will be released, a lot of heat will be released, and then what happen now, this container or this test tube splash out. Okay, this container or test tube will be splashed out, and the acid may fall on your body, and it will be damaged to your body. So please remember that while diluting an acid, what we have to do, we have to add a acid to the
Acid into water.
acid to the water. Okay, acid to the water is the good practice for diluting an acid. Okay, acid should be added to the water, and that is also
Drop by drop.
very slowly, drop by drop, and you have to stir the mixture also, stirring the mixture also. Okay, so here there is one question they will ask based on this. Okay, so concentrated acid, you understand what is my concentrated acid? Concentrated acid nothing but what, how much water is present?
Minimum amount of water.
Minimum amount of water is present. And what about the dilute?
Maximum amount of water.
Maximum amount of water present, or we can say much more of water present in it. So that is the difference between the concentrated acid and dilute acid. Concentrated acid nothing but a acid which contain minimum amount of water, and dilute acid is one which contain the much more amount of water. Okay, so now what the mixture, the process of mixing the concentrated acid with water is actually highly exothermic. Okay, so while diluting an acid, it is always recommended that acid should be added to water. What we have to add? Acid should be added to water, not water to acid. So based on that, one question they will be asking, what is that? While diluting an acid, why is it recommended that the acid should be added? The acid should be added to water. Acid should be added to water and not water to the acid. Okay, this is here very clearly they given that while diluting an acid, the acid should be added to water. See, so why it is recommended that acid should be added to water? Because you know that if the acid should be added to water, okay, then only the heat will be liberated, but not much heat will be liberated. So it will not splash the container out. Okay, but if you will do in another way, if you will add water to acid, then there is an exothermic reaction produced, and which is the temperature increases and heat will be released. In that case, the container will be splashes out and the acid will be fall on your body. This will be damages to your body. So that is why we have to add acid to the water, but not water to the acid. So here I will write the answer for this. Since the process of diluting, an acid is what? Which reaction
Exothermic.
is exothermic? Okay, so it is always recommended that acid should be added to water. If water is added to acid, suppose if water is added to acid, then what will happen? If the water is added to acid, then what will happen? Then it is possible that large amount of what happened? Large amount of heat will be released. Large amount of heat will be generated. And the mixture
Splash out.
splash out and causes burn.
Damage.
That is the answer. Very simple answer. See, since the process of diluting an acid is exothermic, so it is always recommended that the acid should be added to water. If the water is added to acid, then it is possible that large amount of heat generated and the mixture splashes out and it also causes the burn. Okay, so let us now. So here there is one more thing you have to remember, that when you are diluting an acid, okay, so diluting an acid is nothing but the mixture of water and acid. So while dilution, okay, you know, whenever the if in acid the water is present, then what acid will form?
H plus ion.
when water is added to acid or acid is added to water, so we can say that is aqueous solution of a solution of an acid. The solution of an acid always produce water, H plus or H3O plus ion, correct? So whenever you are diluting an acid, it means there is a produce what H plus ion. There is a produce what H plus ion or H3O plus ion. Okay. So this is the H plus ion and H3O plus ion concentration. This concentration of H plus ion and H3O plus ion will be increases or decreases. It will be increases or decreases depending upon the water present in the acid. The concentration of H plus ion and H3O plus ion will be increases or decreases. It will be depend upon the water present in the acid. How much water present in the acid depend upon that. The concentration of H plus ion or H3O plus ion is increases or decreases. Okay, so here let us learn what will happen the concentration of H plus ion while adding the water to the acid. Okay, so here suppose now here you have concentrated acid. Okay, so what will happen now when you are adding the water? So what you will get here, you will get a diluted
acid.
Dilute acid you will get. Concentrated acid and water are mixed. Okay, so what will get here? Diluted acid. Okay, so suppose now if you have like a concentration of acid, and you are adding excess water. What you are adding? Excess water you are adding. Excess water means what? Water. So much of water you are adding. So much of water. It means I can say that 3% of acid and 97% of water. 3% of acid and 97% of water. That is called excess water you are adding. Okay, so in this case what will happen, you know that there is a decrease in concentration of water, H plus
ion.
Why the decrease in the concentration of H plus ion? Because here amount of water is more and the amount of acid is less. Okay, amount of water is more and the amount of acid is less. In that case, there is a decrease in the concentration of H plus ion. Suppose now if you have taken a solution of an acid, what is meant by solution of an acid?
Added in water.
So water is present. Solution of acid nothing but in this acid water is present. Otherwise, what I can say, diluted acid is simple. It is very easy to understand. Diluted acid. So easily you'll understand that diluted acid means water. The water is present in this. Suppose now if you are adding excess acid now, here you are adding what? Excess acid you are adding. Diluted acid means what? Acid plus water is present in the diluted acid. Now what you are adding here? Excess acid you are adding. Means acid plus water is already present. Again you are adding what? Acid. Again acid. So what happened here? Here the amount of acid is increases, correct?
Increase in H plus ion.
Increase in H plus ion.
Correct. Increase in concentration, you should say. Concentration. Increase in concentration of H plus ion. Increase in the concentration of H plus ion. Now, based on this topic, there is a one question from your textbook. What is that? While, how is the concentration of, how is the concentration of, how is the concentration of hydronium ion, H3O plus affected when a solution of an acid, when a solution of an acid is diluted. This is the question. Just now what explanation I done topic this one. Based on this, there is a question they are asking, how is the concentration of the hydronium ion affected when the solution of an acid is diluted? Now any one of you have to give the answer for this. And affected nothing but whether the hydronium ion is increases or decreases. That is the question. Affected means. So a solution
Sir,
of
it will increase, sir. Concentration of hydronium ion increases.
okay, according to you it is increases. What about other student? So here the answer is there in your in the screen only. See, the answer is already in your screen. See here what we have: solution of acid, Okay, in the question given, see the solution of an acid. Solution of acid is diluted. Solution of acid diluted. Diluted means what is the meaning of diluted? Diluted means what? You are adding the
Water.
water you are adding. Already solution of an acid plus water is present. Now in this, what you are adding again here? Here you are adding the water. Now tell me, now I think maybe you can able to give the answer. What will happen to the hydronium ion or H plus ion?
Decrease in concentration.
Decrease in
See
concentration.
this one,
of
see
H
here,
plus.
yes, second point, see that second point I given here. Here, whenever excess water means water, whenever you are adding, whenever the water you are adding, please remember that here, anytime water is come, whenever the water you adding means whenever the acid is diluting, in that case, the concentration of H plus ion decreases.
Decrease.
Yes, it is decreases. And why it is decreases? You know why it is decreases? Why it is decreases? Because the volume of the solution is increases. Volume of the solution. Because if you adding more and more water, then what will happen? Here the solution of the solution will be increases. Here the volume of the solution will be increases. Because of that reason, the concentration of hydronium ion will be decreases. So here I can write when the solution of an acid, when the solution of an acid is diluted. Diluted means you are adding the water. If you are adding more and more water, then what will happen to the concentration of hydronium ion? Then the concentration of hydronium ion will be decreases. Hydronium ion, nothing but H3O plus ion decreases. And why it is decreases? Because volume, okay, because the total volume, because total volume of solution is increases. Total volume of the solution is increases. Total volume of solution increases on addition of water. Mean whenever water is added, no, the volume will be increases. In that volume increases, it means the concentration of H3O plus will be decreases. Concentration of hydronium ion will be decreases. I will give you one simple example for that. Okay, one very simple example. Suppose you have prepared the lemon juice. Okay, lemon juice you have prepared. In the lemon juice, you are adding water, sugar, salt, and lemon. Okay. Now you have already prepared one lemon juice. Okay. The lemon juice you have prepared only the half glass of lemon juice you have prepared, and this lemon juice is ready. In this lemon juice, what we have lemon, water, sugar, and salt. Okay, So many things we have. Now this lemon juice is prepared, already done. Now it tasty. It is very, very tasty. Suppose now your friend comes. Okay. So when your friend comes to your house and you are drinking this lemon juice, so what you will do? You will now give to your friend this lemon juice, but you do not have a lemon in your house. Okay. So what you will do? You want to increase this volume. So what you will do here? You will
Add water.
you will add here
Add water.
Add water.
add your water. So when you are adding water here, so whether the lemon juice will be same taste will come?
No, sir.
No, sir.
Lemon juice taste will be same as before? No.
No,
So,
sir.
so here what I can say, the concentration of, what happened to the concentration of lemon juice?
Decrease.
The concentration of lemon juice is decreases. Why it is decreases?
Because there is increase in volume of solution.
Because of
Increase in volume.
Volume increase. See, before you have prepared only half of the glass of the lemon juice. Now you have added more water. When you add more water, you know that it taste will change. It will not be remain same taste. Here the concentration of lemon taste will be decreases. Why it is decreases? Because the volume of the solution is increases. So here also same way we have to understand that whenever we are adding the water or whenever the acid is diluting, whenever the acid is diluting means whenever the water is adding, so what happened to the concentration of H plus ion or H3O plus ion? The concentration of H plus ion and H3O plus ion will be decrease. And why it is decrease?
Because volume of solution increases.
Volume of solution increases.
Volume of the solution is increases. Base. Now there is one more question is there. Okay, base. Same textbook question. How is the concentration of hydroxide ion? Hydroxide ion, that is OH minus ion affected when excess base is dissolved, in a solution of sodium hydroxide. So this is the sodium hydroxide is a base. So here see, what will be effect on the concentration of hydroxide ion? Means whether the hydroxide ion increases or decreases when excess base is dissolved in a solution of sodium hydroxide. So here you have solution of sodium hydroxide. Here you have solution of sodium hydroxide. And what you are adding here?
Excess base.
Excess
base.
base. So here you have sodium hydroxide. What is the sodium hydroxide? Sodium hydroxide is a base. Sodium hydroxide is also a base. So what I can write here? Solution of base plus excess base. Solution of base plus excess base. Then what will happen? Here is a
increase in concentration of OH minus ion.
Here solution means base plus water is present. Base plus water. Okay, here again you are adding the base. So base you are adding. When the bases will be added. Okay, when the bases will be added, what will happen? Increase in the concentration of hydroxide ion. Okay, increase. See, always remember that whenever, now example, now here you have acid. Okay, acid you have and you are adding the water. Okay, acid and water, and if you are adding here acid and plus acid you are adding. So tell me now, in the first case what will happen? Acid plus water, concentration of
Decrease in
Plus ion
concentration.
decreases.
Decreases. In the second case, what will happen? Acid plus acid, what will happen?
Increase.
Increases.
Concentration of H plus ion is increases. So similarly, in the case of water, base, what will happen now in the case of base? Here you have base plus water. Here also we have a solution of base plus base. So what will happen now? Same thing will happen here. Only in the place of H plus ion, what do you have to write?
OH minus.
OH minus ion. So whenever water is adding now here, whenever the water is adding, so this OH minus ion, what will happen here? Decreases. But when the bases will add, when the bases will be adding, what will happen in that case?
Increase.
So now in this case, what will happen now? In this case,
Increase.
increase. Why it is increase? Just because of you are adding the base. Because you are adding the excess base. If the bases will be added, then there's a concentration of OH minus ion will be increases. If the water is added, then the concentration of OH minus ion will be decreases. So what I should write here, the concentration of hydroxide ion would increases when excess base is dissolved. When excess base is dissolved in a solution of sodium hydroxide. Here is the completed of this answer.